Hi everyone, it's Sorkan. Today we have a problem when we are given a list of the cities and their connection to other cities. For example, in this case, in the example that we are given, we have a city 1, city 2, and the city 3. City 1 is connected to itself, 1. So 1 means that the city is connected to other cities, 0 means that it's not. So in this case, the city 1 is connected to itself, and the city 1 is connected to city 2, right? City 1 is connected to city 2, and it's not connected to city 3. The same way for the city 2, it's connected to itself. It's connected to city 1, right? It's 1. So it's connected to itself 1, and it's not connected to 3. And for the third city, it's not connected to 1 and the 2, and it's connected to itself. And in our case, we need to return the number of the provinces. So what's the province? The province is a group of directly and indirectly connected cities. So for example, in this case, we have two groups, the group 1, right, and the group 2. So, and we are returning as a result 2. Okay, let's take a look at one more example. In this case, we have 4 cities, and for example, city 1 is connected to city 2 and the city 3. City 2 is connected to city 1 and the city 3. We are counting both directly and indirectly. So city 2 is indirectly connected to city 3. And the city 3 is connected to city 1 and the 2, and the city 4 is not connected to any other city. So how are we going to solve this problem? So in this case, we also have 2 provinces, right? The province 1 is 1, 2, 3, and the province 2 is 4. How are we going to solve this problem? The way we're going to solve this problem, we are going to go over each city, and we are going to the first search for that city and mark all the cities that we have visited to true in our visited array of Boolean. And also we are going to maintain one more variable, count, that where we are going to count our provinces, and we are going to return that at the end. So the first, we are visiting first our first node, and for the first node we are, since we have visited that already, we are marking that as a true in our visited array. So we have visited the first city, and also this is our first province, right? So we are increasing our count to 1, and it's our first province. And now we are first searching for the city 1. So we are going to the second city. So we have visited that. We are still in the same province. So we are setting the value in the visited to true. And then we are going first searching. So we are going to the next branch, which is 3. So we are visiting 3, and again setting that to true in our visited array of Boolean. And now we have visited for the 1, we did the first search and we marked all the cities as visited. And now we are going to the second city. Second city is we have already visited that, so it means that it is in the province that we have visited earlier. So we are just skipping that. We are not increasing the count of our province, because with the city is already in other province that we have visited earlier, in this case in the first province. So again, the same way we are going to 3 is already set as true in our visited array, so it means that we have also visited this city. It's in the province that we have visited earlier. So how about 4 is marked as false in our visited array, so it means that we haven't visited that. It means that it's in the new province. So we are increasing, so we are setting the value to true, and we are increasing the count because it's a new province, and there are no other cities that the 4 is connected. So our final result is 2, count 2 that we are returning. So we have 2 provinces, province 1, 1, 2, 3, and the province 2 is 4. Okay, what's the time complexity of this solution? The time complexity is we have 2 for loops. The first loop is that we are going to each city, and we are performing a depth first search for each city. So in the worst case scenario, it's gonna be of n square. How about the time complexity? Time complexity in our case is determined by the size of the array of Boolean, and it's gonna be the size of our input array. It's of n. First thing that we do, we are initializing our three variables. The first one is the n, it's a number of the cities. It equals to the size of the input array. And the other one is the array of Boolean visited, where we are marking each city that we are visiting to true. And the last one is count, the count of the provinces, and we are returning that as a result. So in the next step, we are going over each city. So for example, let's say that we are just starting out and we are going for the city 0. So starting for the city 0, we are, if it's not visited, in this case it's not visited, so we are just starting out. So the first thing that we do, we are increasing the count of our province. So it means that we have one province at least, right? And we are depth first searching and marking every city in that province to true. Every city in that province that is connected to the city that we are visiting directly or indirectly, we are setting that to true. So in our DFS method, so what we are getting as an argument, we are getting three variables: is connected, visited, and the node. A node is the node that is the city that we are visiting right now. So the first thing is that we are doing here, we are setting that variable to true. So we are setting visited node to true, and as a next step, we are going over each its neighbors, and if that is equals to 1, which means that it has connection to that city. So our current node has connection to that city, and we haven't visited that city. So in that case, we again calling our DFS method. So we are recursively setting all the nodes in that province that is directly or indirectly connected to our city. We are setting those to true. And at the end, we are returning our provinces, the number of the provinces that we have counted. Okay, that's it for today. Hope you like my content. If you like it, please hit the like button and subscribe my channel. See you next time. Bye.